Hi, my name is Wendy Fresh, and I'm from Portland Community College. Today I'd like to answer the question, how can I use Desmos in my class? But first, you may want to know, what is Desmos? Desmos is a free suite of math software apps, including the Desmos Graphing Calculator and Scientific Calculator. In other words, Desmos is a graphing tool that I use for so much more in my classroom. In fact, I'm not the only one using Desmos. There are over 40 million teachers and students using Desmos annually around the world. And Desmos has become so mainstream that most U.S. state-level assessments and digital college entrance exams are allowing the use of Desmos. Today I'd like to talk about 4 main ways that I like to use Desmos in my class. The first way is to provide instant feedback. By using the graphing calculator, students can instantly see how changing an equation changes the graph. For example, by typing in the equation y equals x, the student sees a line. If they add the exponent of 2, the line now turns into a parabola. If they change the exponent of 2 to a 3, the parabola turns into a cubic equation. In other words, that exponent has a lot of power and really changes the way a graph looks. The other way that the graphing calculator allows the student to see how the changes made to an equation affects the graph is by using sliders. Sliders allow the user to answer what-if questions. For example, in the function f of x equals x to the second power, what happens as this function goes through transformations? How does f of x compare to y equals a times the function b of x minus h plus k? Desmos recognizes that these new letters represent new variables that vary, and therefore require the ability to change values. The second that Desmos sees these new letters, it prompts the user to add a slider. Now the student can explore the transformations on their own. Which is the second way that I like to use Desmos in my classroom. A perfect example of this is in studying properties of rational functions. I find that my students do better remembering any property if they actually have ownership over it. Rather than me telling them the rules for finding the equation of a vertical asymptote, I let them explore the concept graphically. I also like to provide my students with a handout that they can do in groups or alone that has prompts that I want them to think about. After students complete the first 2 rows of this handout, they may begin to think that vertical asymptotes come from setting the denominator equal to 0, which is almost true. But if they just do this for the 3rd row example, they will not get the correct vertical asymptote. This graph shows that in action. The actual vertical asymptote is x equals -1. Now this should lead them to question why this is happening, which is a perfect opportunity to talk about factoring, simplifying, and wholes. The ability to use the table feature only reinforces these concepts. Using the gear key to show a table of values, you can point out that there's a hole in the graph. Let me show you. Here's the gear function, and when I press that and I click on the table, all of a sudden that function creates a table of values for me. And I can see in this table of values that not only is the function undefined at -2, but also undefined at -1. Now we can see that -1 is the vertical asymptote, and now we can also see that at -2, that's a limitation on the domain, and something must be happening there. What I like to tell my students is if I could zoom in on this Desmos graph, in other words, think about pixel sizes, there would actually be an open circle right here at -2. The third way I use Desmos in my class is to easily find points of interest. Back in the day of only using handheld graphing calculators, finding things like x-intercepts, points of intersection, and so much more took almost as much instruction as the actual concept itself. Desmos has made this so easy and intuitive. A perfect use for this is when teaching how to solve systems of equations by graphing. Desmos quickly allows me to graph 2 lines in any form. Let me show you. We're going to graph, let me hit graphing calculator. And I'm going to graph the 2 lines x plus y equals 1. And I'm also going to graph the line y minus x equals 3. Clicking on the gray dot shows the exact value of this point and therefore the solution to this system. Using the table feature will verify that this point represents a solution to each equation, but you should note that the table feature only works for equations written in explicit form. If I go back to the table feature, you'll notice that the table feature is not present in these graphs. So let me rewrite them. Instead of x plus y equals 1, I will type in y equals negative x plus 1. And instead of y minus x equals 3, I'll type in y equals x plus 3. So I have the same exact pictures, but now when I click on the table feature, the two that are written in explicit form do show a table of values. We said that the point of intersection was at the point negative 1, 2, and sure enough, we can see that in this table of values. If I go down to the second line and also hit table of values, hopefully that point negative 1, 2, sure enough, is there. By the way, while we're in this table feature, you may have noticed that it's only giving me x values from negative 2 to positive 2. I can always go to any x value on the table and change the value to whatever I want. Maybe I'll even go down below where there's no entries and I'll put in a strange number like 7.3 and it'll give me that decimal value. Another place I like to use Desmos is in graphing trigonometric functions. When students are first learning about the graph of y equals the cosine of x, for example, being able to see the graph quickly is really handy. Now that I've cleared the screen from the last example, let me type in y equals the cosine of x, and we can see that beautiful trigonometric function. But the area where my students really struggle with is in solving trigonometric equations. Typically, equations have a limited number of solutions. This is not the case with solving trigonometric equations, where the solution to the equation cosine of x equals 1/2 has infinite answers. If we take this graph of y equals the cosine of x, and we also include the graph of y equals 1/2, where these two graphs intersect will show our solutions. Seeing all of those gray dots in various spots along the graph really drives home the idea that there are infinite solutions. And I can even zoom in with my mouse or zoom out. Another thing you can do to change the way the window looks is by going up to this wrench setting. That's where graph settings are at. And if I click on that, you will see I have the ability to change from radians to degrees. I also have the ability to change the x-axis, which I sometimes like to do. When I first start talking about solving equations, I'm really expecting them to look for exact values. In fact, the interesting points you'll see here, negative 7 pi over 3, negative 5 pi over 3, I'd really like to see those increments on the x-axis. I can make that happen by going to the x-axis and changing the step to some interval of pi. So for example, those all seem to be answers of pi over 3s. So I'm going to type in pi, which is the shortcut for getting the symbol pi, divided by 3. And I will close that. And now you'll see that my axis is in terms of pi over 3. Makes it really nice for students to be able to see those right off the bat. A final way I use Desmos is with the pre-built Desmos classroom activities. To get an overview of the type of meaningful feedback and collaboration that the Desmos classroom activities provide, I'd like to show you this 1-minute video.
Welcome to teacher.desmos.com. At Desmos, our mission is to help every student learn math and love learning math. With that in mind, we've assembled a collection of unique and engaging digital activities. Whether building informal language into academic vocabulary, exploring the relationship between graphs and the situations they represent, or investigating how parameters in an equation affect the graph, you'll find hundreds of activities designed to engage students in mathematically rich tasks in truly delightful ways. And not only that, with the built-in teacher dashboard, you can see student answers in real time, giving you valuable insight for helping individual students and facilitating class-wide discussions. With our featured activities, content bundles, and search features, we make it easy to find just what you're looking for. And best of all, everything you see at teacher.desmos.com is free. Seriously. So sign up, sign in, and start exploring today.
All right, so if you're new to these types of activities, I would really suggest doing the following. The first would be to create a teacher account to be able to save the activities that you want to use. This is free and really easy to do. The next thing is to search for an activity or browse the featured collections. Let me close this video and show you what I mean by that. Up here in the top, you can search for an activity. So if you're doing math or you're doing science, you can look for anything that you want. Lines, let's say. There's obviously a lot of things about lines. The other thing you can do is go to this featured collections area, and you can look at some things that Desmos has already put together for you. So linear systems maybe you want to look at. Another area that you should look at is a new feature that was just recently released, which they've titled Recently Released. These are some of the new things that they have. And then they also have this new feature called starter screens. So screens for checking in, screens for checking understanding. Maybe just at the beginning of your class, you want to start out with something like that. Another thing that I like to do is integrate into my online homework system or my learning management system to be able to use Desmos activities for asynchronous instruction. My school uses Brightspace D2L, and most of my courses are in MyLab Math. And those systems allow me, as you can see the arrow pointing, it allows me to go ahead and put within the assignments a Desmos activity that the students can do on their own, so asynchronously from me. And it's an activity that I want them to do to sort of wrap up this whole assignment. Desmos is really easy for students to use. All that they need is a class code in order to join the class, and you can see that they would enter that right here. They don't have to sign up, put any personal information in, or anything. The final thing that I like to do is to create a student handout that goes along with the activity. So the activity that I would do with solving trigonometric equations, I might give them this handout that they can work in groups or they can work individually on. It allows the students to document their findings and also reflect on their findings. So that would be page 2. Now I know that this is a lot of information, but hopefully this gives you enough information to start looking at the activities. Desmos provides many free trainings as well, and in addition, I've done a full course over how to use the activity builder. So feel free to email me for more information. Thank you so much for listening. I hope that you got something out of this presentation and now can answer the question for yourself, how can I use Desmos in my class? My email is wfresh@pcc.edu. You can email me to find out more, or you can go to my website that I have along with my colleague Jessica Bernards. Anyone can be a mathperson.com. Thank you.